Good morning students, welcome to the session on operating system. In our previous lecture we have started a topic called operating system structures. Okay, in that we have discussed few structures like simple structure, monolithic structure and layered structure, and we have seen the advantages and disadvantages of those particular structures. And in today's session we are going to discuss microkernel and module structures again. Okay, in order to go for microkernel you need to remember about monolithic structure. In our monolithic structure we used to have a kernel part where we will be having all the functionalities built into them, so that your kernel will be taking care of that. Okay, but in case of your microkernel and hardware are separated from your functionalities. I can say, see this, these are the file systems, device drivers and all the services that are available in your operating system will be separated by your kernel, and microkernel will take care of giving the services to the client by using a message passing. I can say what it will use, it will be using a message passing. What it is doing is, it is not taking a complete functionalities within it, it is just providing the services, it is just making the communication between the services and the client. See here, you might not observing this will become a client. Okay, and these all will become the services that are provided by your operating system. When the client want to have the services that are provided by your operating system, it will pass the message to your kernel. Kernel will make a communication between these particular things. Say suppose if I want to have a file server, then I will be giving a message, I will be giving a system call to your microkernel. Microkernel will make a communication between your client and file server, so that they will be communicating by using a message passing method. By passing the messages, it will be communicating. It will be not having any overhead in order to give the services that are provided by your operating system. It will be very easy in order to communicate with your services that are available by your operating system, I can say, whenever the client needs. But in case of this microkernel also, we are having overhead to our kernel, that whenever the client want to communicate with the services that are available in your operating system, it should make a communication between those particular services and to the client. That will become the overhead. Why? Because number of clients will be there, number of requests will come, and those should have a communication between your services, so that it can make a service, it can make utilities of services available by your operating system. You can be clear by saying this. Say suppose this is, we know that we will be working in two modes, one is user mode and one is kernel mode. All the services will be kept in your user mode, we won't keep it in your kernel. Why? Because in order to have a safest usage of your system, we will be putting all the services that are given by operating system in user mode itself. This is the user mode, file systems and device drivers and number of things, and user will be working with what? Application programs. See here, it is not directly communicating with the kernel. When it needs any service, then it will be giving the kernel to its request by using system pass, and then your kernel will make a communication between these particular parts, whatever the services that are available. Say suppose, as I said, you people, if I want to have a file system, then I will be requesting it, I will be passing the message. You can observe this is the message, I will be sending the message and I will be receiving the message. In the same way, when the file system want to communicate with the device drivers, then it will be sending the message, it will be taking the messages. In this way, we will be communicating with our kernel, I can say. It will be not having that much of overhead as we have seen in monolithic structure. These all will fall under your kernel only in case of your monolithic structure, but in case of your microkernel, it is taking few functionalities and it is making the communication between the services that are available and to the client. Okay, that is the major flexibility that we are getting in your microkernel, I can say. Actual hardware components will be there, and microkernel will be managing things, and it will be making the communication by using the message passing method. What is message passing, how we will be doing that, we will see in our later session. For now, consider that by sending the message and receiving the message, we are communicating with the service. Okay, in this microkernel, the major difficulty here comes is that whenever a client requests for number of things, then overhead will be there in your kernel, I can say, in order to make them communicate. Okay, that is the major difficulty in this particular microkernel. Okay, and see, as I said you people that we will be having the safest mode. Why? Because all the services will be kept in your user mode. If there is any problem, if there is any crash occurs in your user mode, then there will be no problem. That part should be repaired and it can be utilized. If we are working in a monolithic structure, all the functionalities will be there in your kernel. If it is crashing, the entire system will crash. That is the major advantage I can say. And let us look for the next one. That is your module structure. What it is? Module structure. The best structure of your operating system is your module structure. See, we have a comparison between your microkernel and your monolithic structure. Here I will be having the comparison between your layered structure and microkernel structure. All the facilities will be there in your structure, I can say, in this particular structure, module structure, I can say. Every functionality, every service that is provided by your operating system will be divided into your modules. Every object will be having its own module and own functionalities, I can say. And every function will be associated with your core kernel. Okay, core kernel. Core kernel will not have all the functionalities. They will be acquiring those functionalities. They will be acquiring those resources. They will be acquiring those services whenever it is needed. It is not loaded directly. When it is needed, then that will be loaded into your core kernel. Say suppose if I want to access the file, then it will be accessed into your core kernel. When I want to have the device drivers will be taken into your core kernel. Like that, we will be having a core kernel which will be taking care of all these things, I can say. Each core component is separate. Every component is separated by a module. And each talks to the others over known interface. Say suppose file system want to access the devices, or else file system want to access the memory, then it will be requesting it your core kernel and it will be accessing the devices. If you want to schedule it, you can schedule it. Like that, we will be having some advantages. Each is loadable as needed within the kernel. If it is needed, then it will be loaded into kernel. Until or unless it is requested, unless it is required, it won't be loaded into your kernel. It won't crash your module, I can say. Okay, a core kernel with 7 types of loadable kernel modules. These are the 7 types of modules, I can say. File systems, loadable system calls and executable formats, stream loaders, miscellaneous modules, and schedule processing, device drivers, file system. Everything is separated by its module, I can say, and it can interface with your core kernel if it is necessary only. So that we will be having a flexibility, and we can compare with this with your microkernel, as we have separated it. As we have separated the services that are available, and we will be having the client or as application program, I can say. But in that particular case, we are having a message passing method that will become overhead for your kernel. But in this case, we are not having any concept because message passing directly it can communicate with the other modules if it is needed. Okay, if it is needed only, then only it will be communicating. Okay, there is no message passing, there is no overhead to your core kernel, I can say. And I can say that it can be compared with your layer structure also. In our layer also, every layer is separated. If you are getting any problem at any layer, then we will move to that particular layer and we will be solving the problem and we will be getting into our system. In this case also, if you are getting any problem at any module, we will go to that module and we will stop that and we will repair it, or else we will give some solution to that particular problem and we will be moving to the next system, I can say. If it is okay, if not, everything will be working as usually. If this got any problem, then remaining part will be working as usual. Okay, if this got any problem, then remaining part will be working as usually. Like that, we will be having the best structure of your operating system as our module structure, I can say. Okay, these are the few structures that we have discussed for you people. Okay, see here, operating system structures, and we have seen how the components are integrated or are interconnected with one another, I can say. In that, we have discussed about the first one, that is simple structure. That is, every component or else every layer is directly associated with your hardware components, where it has been implemented for a system called Intel 8088 structure, where we will be having a direct communication for your hardware components. And then we have discussed about the monolithic structure, where all the functionalities, where all the services will be kept into a single module called kernel. It will be taking care of all these particular functionalities, I can say. If there is any problem, then you need to move through all these things so that you can find the problem, you can fix it. Okay, this is the monolithic structure. Okay, and see the next one is next one that we have discussed is your layered structure. In your layered structure, we will be not having any problem like monolithic structure. We will be dividing all the services, all the functionalities in the layer level, but every layer will be having its own functionalities, own services. But here the problem is that how we are arranging those layers. After what layer, which layer should be placed. That is what the major problem that we are seeing in your layer structure. And then we have discussed about the microkernel, and then we have discussed about the module structure. Do remember, it is very important for your external examinations, and as well as you can go for, if you are going for any competitive examination, they can ask you people which one will be the best structure. So it is not mandatory that always you should use the best structure only. Every structure is having its own advantages and disadvantages. Okay, as per the usage, as per your requirement, you should select the structure. That's it for today. If you are having any doubts, just let me know. I will be placing the notes for this by the tomorrow. Just go through it. It is very important question for your external. Thank you.